A metal ring of mass small m and radius r is placed on a smooth horizontal table and is set rotating about its axis so that each part of the ring moves with a speed v. Find the tension in the ring. So here situation is shown. We consider portion ABC of the ring. Tension is in this direction at point A and tension is in this direction at point C. Now we have to find out the component of tension along the center so that we can get the centripetal force. So for that purpose, here magnified image is shown. This angle is delta theta by 2 and here this angle will be 90 degrees because radius is perpendicular to tangent. Then this angle will be 90 minus delta theta by 2. Now, if we take component of tension along the radius, so that will be T cos 90 minus delta theta by 2. Similarly, for this angle is also 90 minus delta theta by 2. So, component of tension will be T cos 90 minus delta theta by 2. And this will provide centripetal force. So mass of this portion, suppose ACB, we take as delta M. So delta M times V square upon the radius. Now cos 90 minus theta gives sine theta. So this will become 2t sine delta theta by 2 equal to delta M V square divided by R. Suppose this is equation number 1. Now we have to find out the mass of this portion ACB. Since mass of the ring is given as M and its radius is R, so let's write it as capital R. So we can say mass per unit length will be mass per unit length is equal to M divided by 2 pi R. So mass of this portion ACB, which is making angle theta at the center. So we can say arc upon radius equal to angle in radian. So this is delta theta. So arc equal to radius is r times delta theta. So this is length of the arc. So mass of length r delta theta will be mass per unit length times. So let's denote it as delta m. So delta m equal to m upon 2 pi r times r delta theta. So r will cancel out. We will be left with m delta theta divided by 2 pi. So we have got delta m. And in this expression, we can put the value of delta m. So what do we get? So let's write it here. Two t sine delta theta divided by 2 equal to delta m is m delta theta divided by 2 pi times v square upon r. Here delta theta upon 2 we can write under sine delta theta upon 2. So 2t sine delta theta upon 2 whole divided by delta theta upon 2 we can write. So in RHS, we will be left with m upon pi times v square upon r. Now, if delta theta is very small, in that case, this term will become 1. So we will get 2t equal to m upon pi v square upon r. And our concern is to find tension. So tension will be mv square upon 2 pi r. So that is our answer. Now let's take next question. A table with smooth horizontal surface is turning at an angular speed omega about its axis. A groove is made on the surface along a radius and a particle is gently placed inside the groove at a distance x from the center. Find the speed of the particle with respect to the table as its distance changes from center from 0 to L, means from here to here. So here on the particle, when table turns, there will be many forces like its weight in perpendicular downward direction, which will be mg, normal contact force N1 vertically upward by the bottom surface of the groove, normal contact force N2 parallel to the y-axis by the side walls of the groove, and centrifugal force will be centrifugal force will be m omega square x. Other forces will not have any effect because particle is constrained to move along x-axis. That is why I have not written them. And there will be Coriolis force also that will act along y-axis. But since motion is restricted along x-axis, so we will consider only x portion. So we can say acceleration along x-axis is say a. So a will be f upon m, and f is this much. So m omega square x divided by m. So this will give omega square x. And acceleration we can write as dv upon dt. So dv upon dt will be omega square x. Further, we write it as dv upon dx into dx upon dt. That will be omega square x. But dx upon dt is v. So v dv equal to omega square x dx. Now we can integrate it. Suppose we assume that velocity changes from 0 to v dv, and this distance changes from this point is a, sorry. So distance changes from a to L. So we have assumed initially that particle is at x where centrifugal force is m omega square x, but initial position is not x but a. So limits will be a to L omega square x dx. Now we can integrate. We know integration x dx is equal to x squared by 2. So we can put this value here. So it will become v squared by 2 limits 0 to v equal to omega square x squared by 2 limits a to L. So 2 will cancel out from here. So this will become v square upon 2 equal to omega square upon 2 times. We put the limits, upper limit L square minus a square. So 2 will cancel out, and our concern is to find velocity. So v will be equal to omega times square root of L square minus a square. And that is our answer. Thank you for watching.